Your browser has no clue what google.com actually is. When you punch that into your address bar and hit enter, your browser just stares at it like a confused golden retriever. Because here's the thing, computers don't speak website names, they speak IP addresses. That's their language. So when you type in youtube.com or reddit.com, your browser is basically holding a note that says youtube.com and thinking, cool, but how do I actually get there? It's like if someone handed you a business card with just a person's name on it and said, go find them. That's where DNS comes in, domain name system. And yeah, it might sound boring at first, but trust me, this is genuinely one of the most important things that keeps the internet from falling apart. DNS is basically the internet's phone book, except way faster and slightly more chaotic. Think about it this way. You have a friend named Sarah. You don't memorize her phone number anymore. That's ancient history. You just open your phone, search for Sarah, and boom, there's her number. DNS does exactly that, but for websites. Your browser asks a DNS server, hey, what's the actual address for youtube.com? And the DNS server responds with something like 142.250.185.46. That's the IP address, the real phone number your computer needs to connect. Now, here's what makes DNS caching interesting. Every time your computer looks up a website, it doesn't want to go through that whole process again. That would be exhausting. So it saves the answer, it caches it. Your computer, your router, your ISP, they all keep little notebooks of recent lookups. Let's say you visit reddit.com. Your computer asks a DNS server for the IP address, gets the answer, and then writes it down in its own cache. Next time you want to go to reddit.com, maybe 5 minutes later, your computer doesn't bother asking anyone. It just checks its notes and goes straight there. Way faster. But caching doesn't last forever. That would be a problem because what if Reddit's IP address changes? What if they move servers or upgrade their infrastructure? Your computer would still be trying to reach the old address, like calling a phone number that got reassigned to someone else. Awkward. So every DNS record comes with something called a TTL, time to live. It's basically an expiration date. The DNS server says, here's the IP address for reddit.com, and this answer is good for, let's say, 300 seconds. After that, your computer has to ask again. It's like milk. Fresh at first, but eventually you got to check the date. Different websites set different TTLs. Some are short, like 60 seconds, because maybe the website is doing some behind the scenes infrastructure changes and wants to control how long old information sticks around. Others might set it to 86,400 seconds, which is a full day, because their setup never changes and they want to reduce the load on their DNS servers. Your computer isn't the only thing caching DNS records, though. Your router does it too. So does your internet service provider. Even the DNS servers themselves cache answers they've looked up for other people. It's caching all the way down. Let's walk through a real example. You're sitting on your couch, you open your laptop, and you decide you want to check out some random website. Let's say example.com. You've never been there before. Your browser asks your operating system, hey, do we know the IP address for example.com? Your OS checks its DNS cache. Nope, nothing there. So your computer sends out a query to your configured DNS server. Most people use their ISP's DNS server by default, but you can also use public ones like Google's 8.8.8.8 or Cloudflare's 1.1.1.1. Your computer basically yells into the void, yo, what's the IP for example.com? Now, your DNS server checks its own cache first. Maybe someone else on your ISP just looked up example.com 10 minutes ago. If so, the answer's already there and your DNS server just hands it over. Bam, you're done. You get the IP address, your browser connects, and you're on the website. The whole thing takes milliseconds. But let's say your DNS server doesn't have it cached either. Now things get interesting. Your DNS server has to go on a little quest. It starts by asking one of the root DNS servers. There are 13 of these root server systems. Well, technically way more than 13 physical machines, but they're organized into 13 groups with names like A root, B root, and so on. They're run by organizations like NASA, VeriSign, and a few universities. These root servers are basically the phone book's table of contents. Your DNS server asks the root server, where can I find example.com? The root server doesn't know the full answer, but it knows who might. It says, I don't know about example.com specifically, but I know who handles all the .com domains. Go ask them. And it gives your DNS server a list of TLD servers, top-level domain servers that manage .com addresses. So your DNS server goes to one of those .com TLD servers and asks again. Hey, I'm looking for example.com. Can you help? The TLD server also doesn't have the exact answer, but it knows which DNS server is authoritative for example.com. It responds with something like, you want to talk to ns1.example-dns.net. That's the guy who actually knows. Finally, your DNS server reaches out to that authoritative name server and asks one more time. And this server actually knows. It's responsible for example.com. It holds the zone file, the master list of all DNS records for that domain. It replies with the IP address, and your DNS server takes that answer, caches it for later, and sends it back to your computer. Your computer also caches it. Your router might cache it too. Now, for the next however many seconds that TTL says, everyone along that chain can just use the cached version. No need to ask again. It's efficient. This whole process is called a recursive query, by the way. Your DNS server does the heavy lifting, chasing down the answer on your behalf. That's why these servers are sometimes called recursive resolvers. They resolve the query by recursively asking other servers until they get the answer. But not all queries are recursive. Sometimes your computer does what's called an iterative query, where it asks each server itself and follows the chain manually. That's less common for regular users, but it happens. Okay, so caching speeds things up. That's great. But what happens when something goes wrong? What if the cache gets poisoned, meaning someone tricks a DNS server into caching a fake IP address? That's a real attack, by the way. It's called DNS cache poisoning, and it used to be a pretty big deal. Here's how it works. Let's say an attacker wants to redirect people trying to visit bank.com to a fake website that looks identical but is actually controlled by the attacker. If the attacker can somehow inject a fake DNS record into a caching DNS server, one that says bank.com points to the attacker's server instead of the real one, then everyone who queries that DNS server will get the wrong answer. And because it's cached, that wrong answer sticks around for hours, maybe even days, depending on the TTL. Thousands of people could be affected, all getting sent to a phishing site without realizing it. Pretty scary. Fortunately, modern DNS servers have defenses against this. They use randomization techniques, query ID checks, and something called DNSSEC DNS security extensions, which adds cryptographic signatures to DNS records so you can verify they're legit. But cache poisoning is still a risk if systems aren't properly secured. Another thing that can go wrong is just normal human error. Let's say a website administrator accidentally sets a really long TTL on a DNS record, then realizes they made a mistake and changes the IP address. Too bad. Everyone who cached the old record is stuck with it until the TTL expires. That's why you sometimes see advice like, clear your DNS cache when a website isn't loading right. You're basically telling your computer to forget its old notes and ask again. How do you actually clear your DNS cache? On Windows, you open a command prompt and type ipconfig/flush DNS. On a Mac, it's a bit more complicated depending on your version, but usually something like sudo /flushcache or sudo killall -hu pmdns responder. On Linux, it depends on what DNS caching service you're running, but sudo system d-resolve --flush-. Caches is common, and just like that, your cache is wiped. Fresh start. Routers also cache DNS, and sometimes clearing your computer's cache isn't enough. You might need to reboot your router or log into its admin panel and manually clear its cache if it even gives you that option. Most home routers don't make this easy, which is kind of annoying. DNS caching also plays a role in content delivery networks, or CDNs. Companies like Cloudflare and Akamai use DNS to route you to the server that's geographically closest to you. When you query a domain hosted on a CDN, the DNS server might return different IP addresses depending on where you are in the world. And because those answers are cached, your computer keeps going to that nearby server, which makes websites load faster. One more thing, DNS caching can sometimes cause issues during migrations. Let's say a company is moving their website to a new hosting provider. They update their DNS records to point to the new server. But because of caching, some people are still being sent to the old server for hours afterward. This is why IT folks often lower the TTL ahead of a migration, sometimes down to 60 seconds or even less, so that cached records expire quickly and everyone gets the new information faster. There's also something called negative caching, which is when a DNS server caches the fact that a domain doesn't exist. If you try to visit a website that doesn't exist, like asdfeajco123.com, the DNS server will cache that "nope, not found" response. That way, if you accidentally type it again, your computer doesn't waste time asking the whole DNS chain again. It already knows the answer is "doesn't exist." And yeah, this can be annoying if you're setting up a brand new website. You register a domain, set up the DNS records, but your computer still thinks the domain doesn't exist because it cached the negative response from a few minutes ago. You have to wait for the cache to clear or manually flush it. DNS caching also has privacy implications. Because your ISP's DNS server caches all the queries from everyone on the network, your ISP can potentially see every website you visit just by looking at the DNS queries. Even if you're using HTTPS and your browsing is encrypted, the DNS query itself often isn't, so your ISP knows you looked up reddit.com, even if they can't see which specific page you visited. That's why encrypted DNS has become a thing. Protocols like DNS over HTTPS, DOH, and DNS over TLS, DOT encrypt your DNS queries so that your ISP can't snoop on them. Major browsers like Firefox and Chrome have started supporting DOH by default, routing your DNS queries through encrypted connections to servers run by companies like Cloudflare or Google. It's not perfect, but it's way better than sending everything in plain text. So yeah, DNS caching is this invisible thing happening constantly in the background, making the internet faster and more efficient. But it's also got its quirks, security risks, privacy concerns, occasional headaches when things go wrong. And the crazy part is, most people have no idea it's even happening. You just type in a website, hit enter, and it works. DNS handles billions of queries every single day. Without caching, the internet would grind to a halt. Every single page load would require multiple round trips to root servers, TLD servers, authoritative name servers. It would be painfully slow. Caching keeps everything moving. Next time your browser instantly loads a website you visit all the time, just know there's a good chance your computer didn't even bother asking a DNS server. It just checked its notes and went straight there. That's DNS caching doing its job.